Oh. Now this lovely young lady has a PhD in psychology, which makes for an interesting match with all the crazy password people in the audience, I would say. And she has done several talks at PasswordsCon before, and I'm absolutely sure she will do once again a perfect, magnificent talk about passwords and psychology. So I will just leave the stage for Jeunese Payne, please.
Okay, so as Per said, I'm Jeunese and I'm a psychologist. This will be my third time at PasswordsCon. I've given presentations before on the psychology behind the problem with passwords and about the decision-making processes in password practices. This year I'll be giving you this short tutorial where I hope to separate some of the truths from the half-truths about the psychology behind graphical passwords, which have been hailed as a usable alternative to text-based passwords, even though they haven't been widely adopted. And I should point out that this isn't my new research contribution or anything, but I do hope that you'll find it interesting and that you might be able to take something away from it. Also, I'm really nervous and I have a cold. So what appears to be happening in social science is that people hear an easy to describe, interesting psychological phenomenon, and then they run away with it, way off into the distance. And an example that most of you have probably heard of is the magical number 7. For those of you who haven't heard of the magical number 7, in 1956, George Miller, who was a psychologist, put forward the argument and evidence to support it that if the human mind could retain about 7 chunks of information in their immediate memory, plus or minus 2 items. But the problem, since then it keeps getting used over and over again in all sorts of fields. People love this magic number 7. And the problem with that is that the magic number 7 only really applies to the cognitive processes involved in the retention of very simple stimuli, and not complex information processing that's otherwise involved in everyday tasks, which means it's often incorrectly and over-applied to many things. And to the same degree, to a similar degree, the same can be said for the psychology used to prop up graphical passwords. And so, with this in mind, this is the structure of the tutorial. I'll give a brief background. I won't go too much into the story of woe about passwords. We all know about it. I'll talk about memory claims used to prop up graphical passwords, which will involve me talking about the picture superiority effect. It will involve me talking about recall. It will involve me talking about recognition. Then I'll talk about some of the potential problems with graphical passwords. And then I will round up and answer any questions if I have time and should you have any. Okay, so knowledge-based authentication is the most common form of authentication, typically taking the form of a text-based password. And like I said, we're all very familiar with the story of woe about the usability and security issues of passwords. And there are 3 main categories of solution for dealing with this. You could implement a biometric-based system. You can implement a token-based system, all right, Per? Implement a token-based system such as Pico, which I believe Frank has already talked about, or you could just improve the current knowledge-based system, and graphical passwords are one proposed way of improving the knowledge-based system. I love it when men creep up on me.
We got some.
It was just the way you did it as well. Okay. Oh, now I can hear myself as well. Cool. Okay, so before I talk about why people hail graphical passwords as a more usable alternative to text-based passwords, I should mention that there are 3 main types. There's cognometrics, which involve recognizing images amongst an array of other images. You have locometrics, which involves clicking on target points within a single image. And then you have drawmetrics, which involves recreating a drawing or a shape, like you do in Android Unlock, for example. Okay, so graphical passwords. There are 2 main claims used to prop up graphical passwords. But I'm not saying they're incorrect at this point or anything, and they're not necessarily independent of each other. First, we have the claim that pictures are remembered better and for longer than words because of the picture superiority effect. And then we have the claim that recognition outperforms recall, which is only really relevant for cognometrics rather than the other two types of graphical passwords. And I'll look at these in more detail. So, studies have uncovered important differences in the way that pictures and words are processed and remembered. And in general, we have memory superiority for pictures that's better than for words. So in a study by Nelson, for example, Nelson and colleagues, if you give people a long list of words and a long list of pictures, they'll remember about 10% of words after 3 days and 65% of pictures. And so the question is, why might this be the case? Well, first, people can grasp and remember concrete concepts better than abstract ones. So if you give someone a picture of an object, that's a concrete concept. And concrete pictures tend to be better than remembered better than concrete words, which are better remembered than abstract words. Second, pictures are more visually distinctive than words and produce a richer sensory perceptual representation in memory, making individual pictures stand out more. Third, pictures give the perceiver more direct access to meaning. Fourth, pictures are processed more elaborately in that any picture you see tends to be matched with prototypical images that you already have in your mind of the same category of thing. And finally, pictures are proposed to access two memory stores, one verbal and one visual, which increases the probability that you'll retrieve the memory of the picture. Arguably, the same can be said for words, in that you can imagine a picture to go with the word, but that's less likely to occur as spontaneously as it does with pictures. So if I see a picture of a ball, I'm also more likely to think of the word ball. If I see the word ball, I'm less likely to think of the picture that goes along with it. Okay, so many of these claims come from tests of episodic memory in which the participant is asked to recall a list of pictures or words. A typical recall test might ask you to memorize a list of words like on the slide here, and then to recall them later without any cues. And this might be okay with 7 or so words like here, but the longer the list, the harder it gets. And this is because in a free recall test, you typically have very few cues to help you remember all the items appearing in the list, which is especially hard for items in the middle of the list. And in this case, that would be words appearing next to the word father, which was in the middle here. While words appearing at the beginning and the end will typically be remembered better due to well-documented primacy and recency effects. And the type of graphical password that relies more on free recall would be a draw metric scheme. And as we know from research by Marcus and Marte, who was under Payne last year, we know that people can draw that people like to draw certain shapes and start in a certain location. So it's quite predictable. If you had more cues, the material in the middle would be easier to remember, and in a lab-based setting, this typically involves pairing words together so that when you show the participant one word, then they're more likely to remember the word that was paired with it. And in the type of graphical password that relies more on cued recall would be a locometric or a click point type password. And again, we know in the password community that people will often choose points that are very similar to each other. So if you've got a picture of a face, then most people in this room, one of their points that they click will be the face in that picture. And finally, we have recognition, which is the most likely to result in memory retrieval because there is a full copy of the word that you're trying to remember in the cue. And this is what cognometric graphical passwords like passphrase rely on. Bless you. The argument when it comes to graphical passwords, especially cognometric passwords, is twofold. First, recognition is better than recall, although not always, and that's because it relies on implicit and automatic memory processes. So for example, it would be easier for you to recognize a picture of your own country than it would be to draw it from your memory in all its detail. Second, our capacity for recognizing images is greater than our capacity for recognizing words. And in fact, Standing, who tried to find our upper limits of recognition memory, found that we could recognize 10,000 pictures the following day, and he measured this by getting people to tell what was old and what was new from a list. However, we might not want to place too much emphasis on this, since others, such as Shepard in 1967, also found that word recognition was very accurate. It was 90% accurate if you force participants to make a choice. Standing himself also found that despite greater accuracy with pictures, the retrieval time for words was better. And also, many of these experiments only involve distinguishing old pictures from new pictures, which does not necessarily mean that the participant actually remembers the picture and all the details of the picture. So, thanks. I look good today. That's a joke. Okay, I'll describe an analogy for you to get across the point, and it's called the butcher on the bus scenario. I don't know what inspired this analogy, but here it is nonetheless. A man gets on the bus, he sees someone he recognizes, he knows instantly that he recognizes him, but he cannot for the life of him know where he's met him, what his name is. Later on, he's in the supermarket, he goes to pick up a piece of meat, and then he starts to think, oh wait, I know where I know this guy from. He's the butcher from my local butcher. And so what happened here was that on the bus, he got this feeling that he knew the guy, which is recognition. But later on, he had to go through a conscious retrieval process where he actually recollected where he had seen this guy before. Now if we substitute the butcher for a graphical password, you may be familiar with some pictures. You may go, I know that picture from somewhere. But you don't necessarily know all the details, like what order your pictures go in, or for what services that you're supposed to be using what type of pictures for. So what I'm talking about here is knowing the difference between knowing and actually remembering something. Like I said, knowing is fast-hitting feeling, and in comparison, recollecting is, in comparison in terms of like how fast your brain works, is a slow conscious process. And so can we really say that pictures are actually being remembered when we talk about graphical passwords? And this is important because the user of a graphical password has to do more than simply recognize images. They have to remember things like the order of the mouse clicks or how the shape was drawn. And you may well end up with some of the same problems associated with the proliferation of traditional passwords in terms of usability and security. For example, if you let users choose their own passwords, they tend to choose quite predictable graphical passwords, just as they do pick predictable text-based passwords. These passwords tend to be lower in entropy. Just like text-based passwords also, they can be shoulder surfed, and they can be stored and shared by just taking a picture of it with your smartphone. And additionally, despite claims of graphical passwords being more user-friendly, they tend to take longer to log in with, and so people don't really like using them. And finally, if graphical passwords became widely adopted, users would have to remember a different graphical password for each site, which could lead to errors and interference, just as text-based passwords lead to errors and interference. In fact, just like verbal memory, visual memory representations are subject to interference by items that are categorically similar, although interestingly, according to Conkle and colleagues at least, the perceptual distinctiveness of an image, such as color and shape, has little impact on interference. And so this means that what we already know affects our memories, and only with a detailed conceptual knowledge, such as, this is a red sports car and that's a red racing car. Only with this detailed knowledge are we able to maintain detailed representations in our minds that we can then later accurately retrieve. So given all this information, if you take nothing else from this presentation, I want it to be that there are always caveats wherever a psychological theory or phenomenon is used to justify anything. Even visual memory has limits, which means that even graphical passwords have limits, even though the psychology underpinning graphical passwords might be correct. Okay, so in summary, I got there a lot quicker. Okay, so many of the claims made by people to uphold graphical passwords are not in themselves incorrect. Recognition is generally better than recall, and there is such a thing as a superiority effect. But while it is true that a lot of information can be stored in visual long-term memory, both in terms of the number of items and the level of detail per item there are a number of ifs and buts. And these are the ifs and buts. If graphical passwords were to be widely distributed, there's still room for interference and error, both between images in a single thing and between services. You might get confused about the order that they go in or the order that the clicks go in. I would also caution how much emphasis you place on recognition, being better than recall. And finally, we should keep in mind that visual memory capacity is intrinsically tied to what we know about what we're seeing. And without this knowledge, people maintain only a gist-like representation of what they're seeing, which is separated from the perceptual detail. So again, the take-home message from me is that whenever you hear about some psychological theory or phenomenon being used to justify a design decision, don't just take it at face value. The psychology might be correct, but the conclusions drawn might be incorrect or invalid, and there is usually a bigger picture to consider. Thank you.
So there has to be questions for this one.
Of course, but leave it to others.
And just a little bit nervous this time as well?
I was very nervous. Yeah,
I
sorry.
just don't.
I think that came across a bit.
The first time Jeunese did a talk, I have to say this, the first time Jeunese did a talk back in Bergen in Norway, Ireland, she also finished in like record time. The entire audience was like, in a way, I'm going to say starstruck, because we had never had a talk from a psychologist before about these things, your ability or disability or, to remember passwords. And there are so many things related to this that, us as security people don't know about, that I think we should know about. And also on the topic of graphical password schemes, in Las Vegas, when I did a conference in Las Vegas in the beginning of August, a friend of mine in the US named Mark Burnett did a talk there about graphical password schemes and how he essentially hates them. And one of his slides actually shows that on his count, there are more than 19,000 patents in the world now for different types of graphical password schemes, believe it or not. And even more are coming, unfortunately. But questions for Jeunese? Jeff.
Of course. Well, first of all, thank you for taking the opportunity to correct people about. I mean, George Miller's paper was excellent, groundbreaking, all of that, but a long time ago. But anyway, separate thing. My intuition, based on no data whatsoever, is that there will actually be more interference with graphical passwords than with lexical ones. Particularly because things that are done with the text-based ones, the words, these are made up of combinatorial units, while graphical things can often be more analog. They move along a continuum instead of, are you using this letter versus that letter? But I'm wondering if there's any research to either support or contradict my intuition.
There may be research on it. I don't actually study memory or anything, but there may be research on it. But I would actually probably, if I were to go with an educated guess, I'd actually disagree with you and probably say that there's more interference with words, because words you have to be able to interpret first before you get to the meaning, whereas the picture you get directly to the meaning immediately. And also with words you can get letters mixed up, which is or you can have very semantically sleep and snooze. If you get people to remember those two, and they're more likely, or get them to remember sleep, and then you show them the word snooze, they're more likely to say that they saw the word snooze. Where if you get a picture of someone sleeping this way or that way, then I would guess, but I don't have anything to support that you would find it easier to tell the difference between the two images than between snooze and sleep.
This guy.
So I've actually done a great deal of work in this space.
Yeah, I've got a reference for you here. Here on here. Here at the bottom there, near.
Yeah, basically looking at the differences between recall, acute recall, and recognition, so I can actually sort of speak to this. That it depends also on the design of the password system, that the kind of assumption under most recognition password schemes is that So this makes interference a really big problem. That if you see the same image in the set of images used for your bank and for your email, that you sort of have to remember an extra piece of information. Oh, I clicked the apple when it's the bank, but not. So it no longer is recognition. So managing those image sets and working to prevent this becomes very difficult and very, very fast with passwords. But it's much easier with sort of queue recall type schemes where there's only one image involved. And so as to whether there's less or more, it's hard to know, but it's definitely a bigger management problem as you rely on more.
Gentleman in the middle. Next to you, Elizabeth. You had a question? Simple. Okay. More questions?
Yeah. Do you have any data on the entropy that can be garnered from?
There are papers about the entropy of graphical passwords, but I don't have any personally myself.
More questions? Gentlemen, and afterwards?
If you're someone adopts a graphical password technique, have you any studies into it improving overusage in time?
Yeah, that's one of the main limitations to these studies. They often do them immediately. It's the same with word recognition tests as well. They often do them immediately afterwards. I'm sure there are studies where they do it over a certain period of time, but I haven't had enough time to read all the papers out there. So I've got 2 slides of references, but that's all I read for this presentation. And I obviously have my undergrad psychology knowledge of memory as well, but that's it.
That's it?
I'm wondering, so in the technology industry in general, there's a lot of, hey, we read this one paper about psychology, and now we built our whole product around
Yeah,
it.
yeah.
And it's not just passwords, it's everything.
Yeah.
In my case, I see a lot of it in education. I'm wondering if we wanted to push back and maybe have some touch points for where to start discovering and asking questions. Are there specific places that you could point us to?
I think-
or just questions we should ask?
I think what you need is you need a multidisciplinary team where there's mutual respect for every member in the team, and you need a psychologist on the team, you need a programmer on the team, because otherwise you would have to become an expert in psychology. And the problem is that many of the things that they use, for example, when I worked for NCR, all the technology adoption stuff talks about specifically one type of, it talks about the theory of reasoned action, or they'll talk about low-level processing and deep-level processing, but they'll talk about the most famous model and not a more recent model or a model that's more appropriate. And if you employ an actual psychologist, then they'll be able to tell you there are other models. But what happens is that you see it in one paper, and then you think it's legitimate to just reference that one, and then it just happens over and over and over again. So it doesn't just happen with passwords; it happens with human-computer interaction and usability as well. So I would just say interact more and talk more to each other, and stop believing that what you know is the only thing that can possibly be correct. So that was my advice anyway. Yeah. Sorry, it's you that's picking people, sorry.
Yeah. Okay.
Is there any research done on aging?
Of aging?
Aging. In particular, I'm thinking of a reset question, password reset question. What's your favourite colour? I have to remember what the favourite colour I had 10 years ago when I registered for the account. Is there any research on how long people can recall the images?
Probably.
Okay.
I'm sorry.
There is a fun paper that I would say maybe it's a little bit related. It's a pretty new one. Joseph Bono, who used to study here with Frank, and some other people in the US at Google, they looked into security questions and answers from Google, from people all around the world. And something as simple as, what is your favorite food? And they found that, well, that really depends on, first of all, what kind of food do you like? Depends on which part of the country, or the part of the world you live in. But not only that, but in some countries, they have a much wider selection of food. So they found that in some countries, remembering what is your favorite food as a security question would be a lot harder to recall than in other countries. So kind of fun. But that was the last one. I will again say thank you to Jeunese, and we'll have a next speaker in 3 minutes. So thank you, Jeunese.